So here's one example here that I like, just so we kind of talks you guys through all different cases here. And we're going to pick it up right at the end of the one triangle.
So there's the summary there. Now let's move on to two triangles. Now that I make this third side of the measurement, then create two triangles. So first let's wrap up what we did before. If this side, the height still is 2.29. If this side is bigger than the height and the third side, like the previous problem was 4, if we make it 5, if we make it 6, it's going to create one triangle. If we make it anything less than 2.29, it's going to be no triangles. Like if this side's 1, but this side is actually 2, there will be no triangles.
So what he's done here is kind of set this up in a way that when you find this h, just doing a simple sine ratio, so sine of 50 is h over 3, so we multiply the 3 across. If we set this AC to be bigger than that h, there's only one triangle that can happen with it. Okay? If we set that AC to be less than that h, if that guy swings through, it won't make a triangle. Okay, the three sides won't hit each other. So now we're going to make it a length that we can have two triangles with it.
Let's put in a number that's in between the height and the third side. And let's demonstrate why that would create two triangle situations. So here we have 2.5. It's certainly bigger than the height, so the triangle exists. What makes it create two triangles? What happens there? Let's go back to the script, and you can play around with this on the page if you'd like. Here's the situation as best as I can describe it. Get it. This is the 49.9 degrees instead of 50. That's 2.98. But here's the 2.5 side. Let's swing it down and see where the two triangles come from. First, the triangle that most people hear with the lowest side is this one. But notice that.
So that's what you're going to get every time you do law of sines. You'll always get the acute angle down there. And then you get everything else from there. But it can also be this, the side can also swing through in the other place from A to C2.
I can bring it past the height, and since it's less than the third side, you can see there is the second triangle right here. So there is two triangles that are created in this situation. And to summarize it, if this side here that's moving, in this case 2.5, is bigger than the height and less than the third side, it's going to be able to swing around and create two triangles. It looks like here's the two triangle with 50, 2.3, and 2.5. And then over here, an acute triangle with 50, 2.3, and 2.5. Let's summarize this. What creates two triangles in a summary?
And lastly here, I really like this one because it's going to show you the triangle actually pulled apart from this.
See, angle up top, and then using the law of sines, we finish this.
So he just started with the stuff here in the red and did law of sines to get the 66, and then they add to 180 to get this guy up here.
Up, and we get 2.91 on the bottom. Now most kids will leave it like this and they'll say that that's the only triangle. Because we did the test, we now know that there are two triangles. So where does it come from? Where are the two triangles? So this is what happens when we put that triangle on the other side. What happens, this 2.5 rotates over to here. And what's created here is another triangle inside, which is isosceles. And so we know if this is 66.82 degrees, this angle over here is because these triangles, right? This is an isosceles triangle. Therefore, the angle inside here will be 180 minus this angle. So this is the second triangle that we must solve right here. We know that.
And as you do that, you can see how this angle A the first time through was 63. When you come to try and solve this guy now, it's going to be much, much smaller. Okay, but this side staying at 2.5. Okay, inside BC here used to be a really long length because of this guy up here. Now BC in this little tiny triangle is going to be cut down because we made this angle smaller. Okay.
This is 50 degrees, 2.5, just like this one. It's going to be obtuse. So by taking 180 minus 66.82 degrees, we get this angle to be 118.13 degrees. And then just like the first triangle, we get 180 minus those two gives us the 16.82 degrees.
And then you're going to have to go do law signs to find the new BC. Okay, but we will work on that tomorrow.